The moon is losing its white glow and becoming increasingly red. Why? All because it's getting rusty. What's more surprising is that Earth's atmosphere might be what is causing it. But how? Let's get into it. The term rusty here refers to iron oxide, a red compound that forms when iron is exposed to water and oxygen. Mars, the red planet, for example, gets its nickname from the reddish hue that blankets the planet, which results from the iron on its surface combining with oxygen and water. But if this chemical reaction involves oxygen and water, how does rust form in a dry, atmosphere-less environment like the moon? That is exactly what a team of scientists have tried to figure out after they detected rust on the north and south poles of the moon. The rusting on the moon's poles was first discovered in 2008. The observation data was sent by the JPL Moon Mineralogy Mapper, an instrument which traveled along the Chandrayaan-1 orbiter of the Indian Space Research Organization. When scientists examined the data, they noticed that the spectra, which are the wavelengths of light reflecting on the moon's surface, on its poles registered differently than the rest of its surface. They found that there were iron-rich rocks producing spectra signatures that matched those produced by hematite, a specific type of iron oxide mineral commonly found on the Earth's surface. It was a shocking discovery since the naturally dry conditions on the moon should not let such compounds to form. After further studies, the team revealed that the Earth's atmosphere extends far enough that it has impacted the environment on the moon's surface. Since the moon is lacking its own atmosphere and therefore is without a source of oxygen, it appears to be getting a supply of oxygen from Earth. This terrestrial oxygen is able to reach the moon through an extension of Earth's magnetic field called a magnetotail. A magnetotail is the region of the magnetosphere of a celestial body, in this case the Earth, that is swept back by the solar wind in the direction away from the sun. However, even with the water found on the moon, there shouldn't be enough to trigger rusting. But researchers hypothesize that fast-moving dust particles that hit the moon might free water molecules locked into the moon's surface layer, or even carry water molecules themselves. Another important condition for rust to form on space objects so close to the sun is that they need to have a layer of protective atmosphere to shield them from the sun's solar winds. These solar winds produce streams of charged particles that hit anything in its path with hydrogen, which acts as a reducer. The presence of this hydrogen hinders the oxidation process needed for rusting to take place. But the moon has adopted its own protective shield borrowed from the Earth's magnetic field that flows to its surface through the magnetotail. According to the study, the magnetotail blocks up to 99% of the sun's solar wind from hitting the moon during every full moon. It's a temporary blanket over the moon's surface during which rust forms. This discovery will reshape our knowledge about the moon's polar regions. Earth may have played an important role in the evolution of the moon's surface. The findings indeed represent much of what scientists still don't know about the celestial objects around our Earth. There is still a lot to be uncovered, even with an object as familiar to us as the moon. So comment down your opinions about this. Do subscribe the channel if you liked the video. Thanks for watching and see you in the next one.